Hello everyone, welcome back to Study Crunch. Now we are going to start off with a new course, that is Signal and System. In this lecture we are going to study about signal, continuous and discrete type. Then we are going to look at some properties of signal: addition, multiplication, scaling, shifting and reversal. Then we'll be moving forward to different types of signals and their examples. So let's start. Okay, so basically, what is signal? Signal is a dependent variable or a function of one or more independent variables. So basically, you have independent variables like x1, x2, x3, so on, that will group as a variable or a function known as signal. So here, f is a function or variable and x1, x2 are the independent variables. Now there are two types of signal, single variable and multivariable. We can write as fx, this is a single variable function, and f of x1, x2, x3 and so on will give us multivariable signal. Now what is a system? So system is a meaningful interconnection of physical components. Suppose we have an input signal, we give it to a system, we apply any of these following operation and then we get a meaningful output from that signal. So this is known as system. So system is basically meaningful interconnection, whereas signal is a dependent variable or a function which is dependent on independent variables. Now there are four types of signal, can be continuous discrete, even or odd, periodic or non-periodic, energy or power signal. Then we have system, static or dynamic, causal, non-causal, time variant, time invariant, linear, non-linear, vertical, invertible, and stable or unstable system. Now let's start off with continuous and discrete type. So basically, what is a continuous type signal? Let's have a look. So continuous type signals are the signals which are continuous at all the values of t. That is, at every t there is one value. Whereas discrete time signal are the signals which are specified only at certain values of t. So we write continuous time as xt and discrete time as x close bracket n, where n is the integer on which we have different values. Now let's look at some properties, like first of all addition. These are the basic addition. So let's start off with, we have x1, we have x2 and we have s. So x1, x2 are the signals which are to be added and s is the sum. So we have 0, 2 which will give us 2. Then we have 1 plus minus 1 which will be 0. Then we have 2 minus 1, 2 plus minus 1 is 1, so we have 1, then so on. So basically we add these signals range wise, like from -3 to -2. What is the value of signal? So we add the signals blockwise. Now let's look at the next one which is basically multiplication of signal, which is also quite similar to addition. So we have 0, 0 into 1 will be 0, 1 into -1 will be -1, 2 into -1 will be -2, 2 into 1 will be 2, then -1 into 2 will be -2. So basically this is also same as addition. Here we are only using the multiplication sign. Next. Okay, so this is very important, that is time scaling. We have two types of scaling, that is time scaling and amplitude scaling. In time scaling, just remember alpha is the term used, or the constant we use is alpha. If alpha is greater than 1, then it is time compression, and if alpha is less than 1, it will be time expansion. So alpha greater than 1, what we do is at 0 the value is 2, and at 2 the value is 2. So at t is equal to 0, we have x at 0 will be 2, and at t is equal to 2, if we write x alpha t will be, alpha we have taken as 2, and at this particular one will be 2. So this is the time compressed signal. In short, what we can do is we can just write the range, that is 0 by alpha to t by alpha and 2 by alpha. So from here we'll be getting the value of the compressed signal. So just remember, when you have a compressed signal, alpha will always be greater than 1. Now let us look at the second case, expansion. In expansion, similar, keeping the amplitude same and divide by alpha. So we have alpha t by alpha, 0.5 t by alpha, and t by alpha. So we have taken alpha as 0.5 because it should be less than 1. In the compression part it should be greater than 1, and in expansion it should be less than 1. So writing it that at t is equal to 0 we'll be getting 0, and at t4 we'll be getting the next value, so it is the expansion. Now let us look at amplitude scaling. In amplitude scaling we use the variable as beta. When beta is greater than 1, we'll say that it is amplified. When beta is less than 1, we say it is reduced. So in time scaling we had time compression and time expansion, whereas in amplitude scaling we have amplitude amplification and amplitude reduction. So for amplitude reduction we have t is equal to 0, amplitude is 2, so we have amplitude, if we put y is equal to 0, then it will be 2 into 2, which will give us 4, so amplitude becomes 4. Similarly at y at 2, it will be 2 into 2, which will give us 4, so we have amplitude of 4. Now let us look at now there is case 2 when beta is less than 1, that is reduction. So here as well we'll do the same thing. We are taking beta as 0.5, so 2 into 0.5 will give us 1. Similarly the amplitude will be reduced. Now we'll be talking about shifting. Shifting is another important topic. We have time shift, that is time delay and time advance. So in time advance means we are before time, so k will always be positive, whereas in time delay k will always be negative, as it is always delayed, that is we have time after that period. So for this, for k plus 2, this will be in advance, that is minus 2 seconds advance. whereas in time delay we have right shift, it will be in the delayed part. Next, amplitude shifting. Amplitude shifting, we have upward shifting and downward shifting. So in upward shifting, k is greater than 0, whereas in downward shifting, k is less than 0. So when k is greater than 0, we'll be having plus 2. If we take plus 2, it will be shifted 2 times up, and in minus, it will be 2 times down, that is 2 units down. So this was all about shifting and scaling. Next we'll be talking about reversal. Okay, this is a special case of time scaling when alpha is minus 1. So what we do is, time scaling we had alpha t, whereas in time reversal we'll be having minus of t. So whatever will be the question, like it is plus 2, then it will be reflection on y-axis in time shift, whereas in amplitude shift it will be reflection on x-axis. So here reflection will be on y-axis and here it will be on x-axis, that is in amplitude reversal. So I hope this is now clear. Now we'll be moving forward to different types of signals. Thank you.